Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on work, energy and power. And this question is from March 2022, paper 2, variant 2. In this question, we will discuss some key concepts about work, energy and power. And those concepts are very important to understand this topic in a proper way to answer past paper questions. For our question number 4, it is given to us a child moves down a long slide as shown in figure 4.1. The child moves from rest at the top, means at this point speed of the child is equal to 0. As speed of the child is equal to 0, we can also say initial kinetic energy of the child is equal to 0. It is also given to us resistive force of 76 newtons opposes the motion of the child. Kinetic energy of the child at point y is 300 joules. So at this point we can say kinetic energy final, this is equal to 300 joules. So this is equal to 300 joules at point y. But decrease in gravitational potential energy is also given, that is equal to 3200 from x to y. Means when this child moves from x to y, the decrease in gravitational potential energy means delta GPE. This is given to us and the value of this one is 3200 joules. Now if we take y as our reference line and we assume at this point h is equal to 0, so we can say final GPE is also equal to 0. So simply we can say final GPE is equal to 0. So we can say initial value of GPE means at point x, this is equal to 3200 joules. For part A, question is asking us to determine the ratio between kinetic energy of the child at y when the resistive force is 76 newtons and kinetic energy of the child at y if there is no resistive force. For this question, first thing we need to understand is kinetic energy of the child when there is resistive force. That kinetic energy is given to us and the value of that kinetic energy is equal to 300 joules. So this value we have. Now we need to find out kinetic energy of the child at y if there is no resistive force. For that purpose, we will use conservation of energy. So we will use this principle of conservation of energy and we will try to find out. We can find this directly, but to give you better understanding, I will apply conservation of energy. Now, if we apply conservation of energy at this point at x, so the total energy at x has to be equal to total energy at y. If there is no resistive force, it means mechanical energy is conserved. We can simply say mechanical energy at x has to be equal to mechanical energy at y. Mechanical energy simply means that kinetic energy initial plus gravitational potential energy initial. This one has to be equal to kinetic energy final plus gravitational potential energy final. Kinetic energy initial is equal to 0. So simply we can say this is equal to 0. And GPE initial is equal to 3200. KE final we need to find out, means the value of KE at point y. And GPE final at y is equal to 0. So the KE final is equal to 3200 joules when there are no resistive forces. So simply we can write down this is 3200. We need to find the ratio between them. Simply we need to divide. If we divide this one, our final answer is going to be 0.094 and this is our final answer. And this question has only 1 mark. If you have got the right answer, you will get this mark. For part B, we need to use the answer in part A to calculate the ratio between the speed of the child at y when the resistive force is 76 newtons and speed of the child at y if there is no resistive force. In part A, we have calculated ratio between kinetic energies when there was resistive force and when there was no resistive force. force. Now question is asking us to calculate the ratio between speeds. In order to answer this question, let's start from kinetic energy. Kinetic energy of a body is equal to 1/2 mv squared. We need to find the ratio between speeds, so we can simply rearrange kinetic energy over speed squared. This is equal to 1/2 m. But if the mass of the body is not changing, if we are talking about the same body with constant mass, means mass of the body is not changing, we can simply say that the ratio between kinetic energy and v square will stay constant. And this is true for this case. When the child is moving from x to y, the mass of the child is not changing. So simply we can say 1/2 m is equal to constant. If this is true, we can also say kinetic energy means the ratio between kinetic energy when there are resistive forces and speed square when there are resistive forces has to be equal to kinetic energy over v square when there are no resistive forces. Now if we cross multiply, means we multiply like this, we cross multiply now, so we can say kinetic energy r times v square. This one has to be equal to kinetic energy times VR square. We need to find the ratio between VR and V, so we can divide this side by V square times KE. So we need to divide this side by V square times KE. Now in this case, simply you can see we can cancel out kinetic energy with kinetic energy, and we can cancel out V square with V square. So simply we left with KE R divided by KE. This is equal to VR squared divided by V squared. But we have the ratio between KER over KE already. That was equal to 0.094. And this is coming from part A. And this is equal to VR squared by V squared. We need to find the ratio between VR over V. So we can take square root on both sides. Means we have to take the root of this 1 by 2. Now if we simply solve this, we will get our final answer that will be equal to 0.31. So this is the answer. This is the ratio between speeds when there are resistive forces and when there are no resistive forces. And this question has 2 marks. First mark you will get if you have written this relationship. So that mark is C mark, KE over V square. You will get 1 mark. Then the second mark you will get if you have got the right answer, and this is answer mark. For part C, we need to calculate the length of the slide from X to Y. But for this question, the resistive force acting on the child is given to us, that is equal to 76 newtons. It is also given to us the value of KE at X means K initial, this is equal to 0. And GPE initial for this question is also given, that is equal to 3200 joules. At point Y, GPE is also given, that is equal to 0. And this is final value of gravitational potential energy, because we are taking Y as our reference point, and at this point we are assuming H is equal to 0. So that's reason GPE final is equal to 0. And kinetic energy at Y is also given to us. We can say this is kinetic energy final, and this is equal to 300 joules. Now simply we need to use conservation of energy to calculate work done by friction. So we will be using conservation of energy. In this case, we cannot use conservation of mechanical energy because there are resistive forces. So we have to use conservation of energy. Means we have to consider work done by resistive forces. At point X, kinetic energy initial, we can say this is kinetic energy initial plus GPE initial. This one has to be equal to kinetic energy final plus GPE final plus work done by resistive forces. Kinetic energy initial is equal to 0 and GP initial is equal to 3200. Kinetic energy final is equal to 300, but GPE final is 0. So here we have work done by resistive forces. So from here we can find out work done by resistive forces. That one will be equal to 2900 joules. So this is the work done by resistive forces, and work done by resistive forces is equal to resistive force times the distance traveled. So we can say distance traveled, and distance traveled is equal to the length of the slide. So simply we can calculate from here d, and this is length of slide between x and y. So we can say this is length of slide. Now we need to find d, so simply we can say this is work done against resistive forces divided by, in this case we have Fr, so simply we can say this is over resistive force. So value of work done against friction or against resistive forces is 2900. We need to divide by resistive force, 76 newtons. So in this case our final answer is 38 meters to SF. So up to SF our answer is 38 meters. And this question has 2 marks. First mark you will get if you have calculated work done against resistive forces, means work done against friction in this case. And the final mark is answer mark. You will get final mark if you have got the right answer. For part D, it is given to us at end Y of the slide, the child is brought to rest by a board as shown in figure 4.2. We have already discussed at point Y, kinetic energy of the child is equal to 300 joules. Now in this case, the child will use this kinetic energy, and this kinetic energy will be converted into EPE, means elastic potential energy, and the value of elastic potential energy is given to us, that is equal to 140 joules. So we can say this is equal to 140 joules. When child will press this spring, so let's say compress this one to this point, so then we can say this is the compression, so this one is the compression x, and this is what we need to find out. Question is asking us calculate the maximum compression of the spring, that the maximum EPE is equal to 140 joules. So we need to find out x. For this question, spring constant is given. It is given to us the spring obeys Hooke's law, and spring constant is equal to 63 newtons per meter. We need to find x. So pretty straightforward question. Elastic potential energy is simply equal to 1/2 kx squared. If Hooke's law is obeyed, so this is equal to 1/2 kx squared. We need to find out x. So simply we can rearrange. We can say this is equal to 2 times EPE divided by k. We need to find x, so simply we can say x will be equal to 2 times EPE, elastic potential energy, divided by k. If we take root of this, this will be equal to x, mean this will be equal to maximum compression, because we are using maximum value of EPE. So this is our x max. Now simply we can plug in these values. EPE is equal to 140, k is equal to 63 newtons per meter, and our final answer will be 2.1 meters. So this is our final answer. Means spring will be compressed by this much, 2.1 meters. And this question has 2 marks. The first mark you will get if you have written this formula. So this is C mark, and the second mark is answer mark. If you have got the right answer, you will get the second mark. For the second part, we need to calculate the percentage efficiency of the transfer of the kinetic energy of the child to elastic potential energy of the spring. So simply we can write down here kinetic energy of the child, means how much kinetic energy of the child has been converted into elastic potential energy of the spring. We need to calculate percentage efficiency for this energy transfer. Kinetic energy of the child we have that is equal to 300 joules, and elastic potential energy is only equal to 140 joules. So simply we can say part of kinetic energy has been transferred into other forms of energy. So other form of energy can be thermal energy, and this is wasted form of energy. So we can simply write down thermal energy, and this is wasted form. So this is wasted form of energy, and this one is useful. So simply we can say this one is useful. Now we need to find the percentage efficiency. So simply we can say percentage efficiency is equal to useful energy output. So we can say useful energy out. energy output divided by total input. Then we need to multiply this one with 100. In this case, useful energy output is EPE, that is equal to 140, and input energy is equal to kinetic energy. We have to multiply this one by 100. If you multiply by 100, our final answer will be 47%. And this is the answer. And this question has only 1 mark. If you have got right answer, you will get answer mark. For the last part, it is given to us the maximum compression of the spring is X naught. On figure 4.3, we need to sketch a graph to show the variation of the elastic tension energy of the spring with its compression X from X is equal to 0 to X is equal to X naught. Numerical values are not required. So first thing we need to understand elastic tension energy. Elastic tension energy is equal to 1/2 kx squared. When x is equal to 0, EPE has to be equal to 0. So means the first point has to be here. It has to be 0. We have to start from origin. And when x is equal to x naught, EPE is maximum. So it has some value, maximum value. But we also need to understand EPE is directly proportional to x squared because 1/2 k, this is constant. So this is constant and this spring obey x law. So simply we can say EPE is directly proportional to x squared. So the shape of the graph has to be parabolic, or simply we can say the gradient of the graph has to increase with x. So gradient has to increase. So simply we can sketch the shape of the graph has to be parabolic, increasing gradient. So simply you can sketch graph like this. If you have sketch like this, it has to be curve. You will get 1 mark, curve from origin. So this is the first mark you will get. And this mark is M mark. It has to be curved. If you draw straight line, you will get 0 mark. And the second mark is if the gradient is increasing. So you will get 7 mark. And that is answer mark. So 2 marks for this question.